Hey, Nathan here. Welcome back to another Unity2D video. In this video, we're going to discuss a couple of things. One, what are scripts and what they're used for, and two, how do we move an object by using a script? So, last video we discussed how to add a PNG file to our assets section at the bottom, and how to add that as a game object in our game so we can see it. So that was a discussion on sprites. We kind of went over it a little bit on the inspector. A lot of the stuff will be covered in a more advanced tutorial. You can just leave the basics as it is. And we discussed the hierarchy on the position, rotation, and scale, and what color means, and we can change the sprite by using this circle. In this video, we're going to add a script, and we are going to move our object with a script. Okay, so what is a script? A script is a file that we attach to our game object where we can write code to perform some kind of action, depending on if we wanted to move our object or handle creating other entities. If we have like a formation that we want to use, we can have a spawner that will spawn enemies in a certain way and move the entire array of monsters around, or anything that we can do in code will be using a script. Maybe you have XML files for weapons or armor or gear or something that you want to have XML files for. We'll need to have a script to read the XML that we can attach to objects. So scripts are classes, and think of them as classes that we could use in our game if we're thinking about XNA and just C++ and just raw stuff that we could use. In Unity, a script is a CS file that we will use to write our code. In this case, we are going to use that to write code to move our object based off the keyboard input we provide. So right now, the object is not doing anything. We play our game, and that's it. I can hit the arrow keys, nothing happens. So I'm going to quit the game. So let's create a new script. In order to do that, you go to your object that you want to attach a script. Now, this is one way to do this. I want to create a script and attach it to our object in one action. So I click our object in the hierarchy window on the left side, and on the right side you'll see Add Component. And we'll add a new script, and let's just call this Movement Script. You can change the language, but C# is what I'm focusing on. So you can hit Create and Add. Alright, now depending on how you have this set up, if I double click this, right now I have it set up to use Visual Studio. So once that loads, we'll get to writing the script. So this is actually building the project, and it will open it as well. And it's taking a little bit longer for me to load because I have ReSharper as well. So a script by default comes with the start and update method. I don't usually use start for my basic scripts, so I'm just going to go ahead and delete that method. So we're just going to use update for this example. So this is a script. We have attached this, we created the script and attached it to our sprite in one action. So this movement script is now attached to our sprite object. And every game tick will call the script's update method. Whenever the object is initialized, whenever it needs to run its first initialize, we use our start method, which I deleted. So start is only called at the beginning when the object is loaded. Update is called every game tick. So let's go ahead and build our update. If. So we want to move our object. So we want to move it if our arrow keys on our keyboard are pressed. So just like with XNA or MonoGame, we do have an input system library that we could use. Input dot get key. So this will use a key code dot up arrow. So this will return a true or false value depending if the up arrow key is pressed. So if this up arrow key is pressed, we want to adjust the position. So let me go back to our Unity here. So if I go to the player paper hierarchy and go to the player paper object, and on the right side we have inspector. We have position here, but look at the group it's in. It's in the transform group. I can collapse this and the position is gone. So position is in the transform group. We want to adjust the position of the Y value if our up arrow key is pressed. But that's in the transform group. So back in our code, we need to actually use that transform property. Transform dot position. We want to increase it. Now I like to use the vector 3 up, down, left, and right. Those identity properties of vector 3. You're not required to use that. You can build the vector 3 yourself, but it's there, it's available to use, and it just saves you time. Vector 3 dot up. So I want to move this up. So vector 3 up. Now, whenever you deal with sprite movements or any kind of physics or any kind of stuff that you will use to move your object or just anything in general, anything that requires an object to be moved around in the screen, you want to use delta time. You do not want to use pixel values. The reason why that is the standard practice is because if one person is able to run the game at like 1,000 FPS, the object will move 1,000 times faster than somebody that can run the game at 1 FPS. But if you deal with time, somebody running the game at 1,000 FPS, or somebody running the game at 60 FPS or 1 FPS, the object will travel at the same speed. It's just updating quicker or slower depending on your frames per second. So, vector 3 up times. So how do we get the time? Well, we have a time property here. Time dot delta time. So that is the change of time between the previous game loop and the current game loop. So vector 3 up times delta time. So let's save this and let's run our game. So we run our game, we hit up. Okay. So now I'm hitting up arrow key and it's moving our object up. But it's a little bit slow. So let's stop the game and let's go back to Visual Studio. I like to add a property here. Now this property will be a public property and I'll show you why. Public float speed is equal to, let's say our speed is going to be 20 right now. So our public property speed is 20. Now I'm going to multiply this by speed. So we are adjusting our position by the vector 3 up identity. We're multiplying that by the change of time between the previous game loop and the current game loop, and we're giving it a speed value we use. In this case, it's going to be 20 for now. So let's save this, and let's go back to Unity. And let's run our game. Let's hit up. So that's a little bit too fast, but I made that a public property, and instead of going back to the code, look at the inspector. There's now a speed property here. So let's change that to 10. Let's run our game. So that's a little bit better. Let's change that to 5. Yeah, there we go. That's good. All right, so 5 is a decent amount. All right, now let's go back to the code and let's do the same thing for the down arrow. If input.getKey code.down arrow transform.position plus equals vector 3.down times time.delta time times speed. Alright, we'll save this. We'll go back to our code, or back to our game, and up arrow, down arrow, up arrow, down arrow. Left and right is still not doing anything. So, let's say if we wanted that to be a little bit faster, let's double the speed. So now we're making that 10. So up arrow, down arrow. So now it's twice as fast as it was before. Without going into the code, we can adjust that speed value. Alright, let's go back to Visual Studio and let's get the left and right done as well. I'm going to copy these two if statements. And I'm going to paste them below, and I'm going to change up arrow to left arrow. I'm going to change vector3.up to vector3.left. And I'm going to change the fourth if statement from down arrow to right arrow. And I'm going to change vector3.down to vector3.right. Save. Let's go back to our game and hit run. Up, down, left, right. So now we have full 2D movement in our game. Up, down, and left and right. So that is how you attach a script to an object and how you move an object around. So a script is a piece of code that we attach to an object where we can perform actions, for in this example, movement actions. You might need to read an XML file. In that case, you'll need to have a script. Things that just need code to execute. Artificial intelligence. Maybe you need to have an object to decide what action to perform next. That will be a script you need to add. Anything other than simply displaying the sprite to the screen, because that's already taken care of by the sprite renderer. So any complex coding or complex task you want the object to do, you'll need to attach a script to that object and write code for that action. For moving an object with the keyboard, you can use the input.getKey. That will return a true or false value if the key is pressed or released. And you can use the key code enumerator to get the, in this case, the up arrow, down arrow, left arrow, or right arrow. You can get other keys if you want. To move an object, if you look at the inspector, it has a position property, but that is part of the transform group. So to move an object in the code, we need to call the transform property and adjust its position. You can use the vector3's identity, which is like up, down, left, and right, to get the appropriate direction that you want. Any kind of adjustment to position or scaling or rotation or anything related to that, either moving an object or physics or anything in general, you want to use delta time. You do not want to use static values like speed without delta time. Because if somebody has a really powerful computer and they can run your game at 1000 FPS, you want the object to move at the same speed as somebody that can run the game at 60 FPS or 1 FPS. It might look horrible, but the object will still travel at the same speed. When you give a public property to a class, to a script, you can access it in Unity's inspector. In this case, we can access our speed here through the inspector without going back to our code. Our code still has 20, but the inspector has 10. So we can adjust a public property of our script in the Unity's inspector. So in that case, if you close your Visual Studio window and you want to adjust the speed of the object without reopening it, you can just change that there, 5. Now it's half as fast as it was before. Alright, so that's pretty much it for this video. I hope you enjoyed it. But the next video, we are probably going to cover more in-depth scripting. In this case, we will restrict our sprite movements to the game window. As you see, if I hold down the left arrow, now the object moves past the screen. So that will be a good topic for the next video. Restricting movement of our sprite object. So stay tuned for the next video, and I hope you enjoyed this one. Thanks for watching.